All right, we might as well begin. Thank you for joining us with this video and hanging out with us in this Twitch stream. We really appreciate it. If you like what we've been doing, definitely like and subscribe. Hit that bell notification to be informed of when we drop new videos on YouTube. Definitely subscribe if you can. We're aiming to hit 1 million subscribers by the end of 2026. It's a crazy goal, but you know what? All things are possible in this world. All things are possible. So let's just get crazy with it and see if it's something that we can do. What the heck, right? So we really appreciate you joining us and being with us on this journey. It's been a learning experience. It's been a lot of fun. So we're going to continue from what we were doing with the last video. The last stream is continue our diagnostics, our troubleshooting of why the Silicon Labs USB UART bridge chip is not working. So what we did in the last stream, the last video, is we pulled the chip, verified that it was actually causing the problem, because with the so let's go over to the one camera. Let's kind of put this stuff back in frame as best as possible. So with the air wires to the TX-RX lines directly on the ESP32 with the bridge chip removed, we can actually program and properly interact with the ESP32. So we're getting serial data out, we're just not getting serial data in. We've checked the raw circuit board, a raw PCB, made sure there's nothing, no weird shorts, no weird connections. There's none. It's a straight B line from the Scilabs chip, the UART bridge chip, to the ESP32. There's nothing there. My suspicions are lingering around a problem with this UART bridge chip. Because now we pulled one, we tested, so we know that works. We put another one back on, a brand new one from the tape and reel packaging, and it refused to work. We have the same exact problem. We get data out, but we can't send data in. So what I'm going to do, one of the first things I'm going to do, if I stop breaking my stuff here, is, so I have a couple of its bigger brothers. The upgraded version of this chip, which does a lot more, and I use them on other projects. So I had a few laying around. So we're going to swap that chip for one of its bigger brothers and see if we get any kind of different output, if we get any kind of different results. I'm not really expecting too much, but before we jump to do that, I want to look under the microscope. Take a little bit better look at this chip. Look at the whatever solder joints we can see. Let's make sure that things were soldered good. Let's see here. So we got the microscope up and running. Go to the bridge chip. All right. Let's see if I can kind of... Nope, we can't. So we'll have to kind of go... It'll have to be upside down. Oh, no, right side up. Okay. So we are a little weak on solder. Okay. You know what? That could be our problem. You know what? I failed to check it as closely as I could have. We're a little weak on solder, so that could be our problem. That's no issue at all. We can manually touch this up with a soldering iron. It's as crazy as it sounds, we can pull that off. So let us go to the other camera on the soldering station. Let me grab my flux pen. So maybe we'll try this first. This may actually fix it. And if it does, yeah, I'll be really happy. I'm really happy if this solves it. As crazy as it sounds, this is something we can actually add a little bit more solder to. It might be just solder starved. And if that's the case, this might actually fix the little guy. So it's solder starved all around it. So we will do our best to feed it and get good contacts with it. I'm really hoping this solved it and it was just a bad chip, a bad reflow, something else went wrong with it. That's fine. So what we're going to do is just kind of try to work, try to get soldered down to the poor little pins. Sometimes it's a hard thing to do, depending on the soldering iron you're using. But it can be done. Worst case is I'll just grab solder and fresh solder, and we'll just my wire solder, and we'll just use a hot air gun and kind of flow more fresh solder onto it. I'm not terribly worried about bridging right yet. We'll deal with that as we go. The main thing is to try to get all the legs soldered. Pain in the rear, but it does work. It can be done. You really don't be afraid to use your flux for things like this. Solder. I can see it going down. Okay, let me kind of take a look under the magnifying lens, see what I can see. I have to go back to the microscope. So I can round that one side and the bottom. Okay, that might be good. Keep trying to get a little bit more. Okay, that might have gotten that. There's a bunch of pins that aren't even connected or even used, so what I'm hoping is that by doing this, we get the ones that are actually connected and the unconnected ones that don't matter. Okay. Is there anything that I can do to clean up? No, that looks fine. I'm going to kind of clean it up with water a little bit. All right. So I'm hoping this solves it. It was just maybe just a solder bridge underneath, and then the water. If this solves it, that'll be good. Maybe the first one just didn't solder good, too much solder. Maybe I nosed it too much. Just kind of, to be truthful, building on camera was a little bit of a harrowing experience. I'm not used to doing that. I'm trying to converse and make dialogue, so too easily distracted doing that, trying to keep the engagement going, so you know I'm not ignoring you. All right, that's good. All right, that's good. Grab this. So this might actually solve our problem. Let's kind of switch it over to the microscope. All right, some of the pins might. Okay. We'll try it. We'll see if we can hit it. maybe we got enough of the pins to connect that that'll work. So let's kind of move that guy out of the way a little bit. Pull our stuff right back here. Find all my cables that have been shoveled around this workbench. I need to go through and fix all this. Let me get VS Code up. Which I failed to do, but you know. Okay, so can we get these? Because if we can get code, if we can get this programmed and solve that particular problem, we will be doing good. Come on, serial ports real quick. Great. Output enabled, nothing exploded, nothing go to smoke. Does the serial port show up? Oh, probably won't because I don't have the cable enabled. Let me see here. That should be. What's going to be this guy? There we go. Nope, that's somebody else. It's probably this guy. There we go. Not enough resources on the controller. So let's turn off the... yeah, I got to solve that problem too. Hello. All right, let me see where in the world you are here. So you're here. That's this guy. That should be off. This guy is to the picoscope. Too many cables. Really need to get better organization, and I plan on it. Okay. Okay, so that is it. It did finally shut down. Let's try back up again. Okay, plenty of resources now. Oh, get my parts up off the floor. Don't want the cats playing with them. All right, so let's go to the main screen right here. So COM22, you down. No. All right, column 22 is selected. All right. All right. I'm not going to give 100% hope. Because... and I'm not getting anything off that serial port. There it goes. Now it wanted to work. I don't know why I wasn't getting anything. Let's try this again. Let's try. All right, we'll try double checking the solder joints, and so we know the serial connection is down here at the bottom. I want to at least check that before I commit to changing this chip out. All right. Okay. Microscope still kicking. Yeah, so unfortunately it does look like the those lines are tied in. So let's grab. Also want to check something out. Here, let's. So. All right. Well. Okay. So we are going to try to pull this guy and try to put a new one on. Loads of fun. As always. New chips right here. Don't want to lose it. Get this guy going. Get warmed up. There we go. I don't know. Okay. That's better. Probably bump that a little bit. All right, little fella. Oh. Come on, buddy. There you go. Grab a little bit of solder. Boom. Oh. What's that bridge that's right there? Getting dangerously close to melting my connector. All right. Jump on this guy. Should be on there. All right. needs to cool off, so I'm not going to touch it too much, but let's just kind of. Looks like we're flowed, doesn't look like there's any bridges, looks like we're good and centered. So let's just keep our fingers crossed, let it cool down, and then we'll give it another try. Give it another round, another attempt. All right. Okay, this guy looks cool enough. Shut him down. Out of the way. Yeah, plate's cool. Guy should be cool enough. Yeah, because if this doesn't work, then I think what I'm trying to do is building a new board. I'll do that off camera. Maybe. Great. I didn't shut that guy down. No, I didn't. Oh, no, that's disappointing. Very disappointing. Maybe too much heat damaged the bridge chip or damaged the soldering pads too many times. Because now we ain't getting anything. Great. The clarity's right. Should be a problem. See if we can see what the solder joints look like. Horrible. Maybe they're just not flowed all the way. Let's try that. Let's try one more thing. This guy warm back up. I switched over to the other camera real quick. All right, so what we're gonna do is we'll add a little bit of flux and we'll heat everything back up. We'll see what we can do. Maybe it just didn't flow right. All right. No. Give it the old secondary try. If that doesn't work, then I think what we'll have to do is actually probably build a second board. Everything cool down first. This is unfortunate, but it's part of the game. It's part of the experience. It's part of doing this type of work. We were doing so good too. The board was looking to be a success at first. It powered up. Nothing smoked. Nothing popped. We at least have single direction communication. We had. Yeah. Disappointing. I think if I do build another board up, I won't populate all the through-hole stuff right away. Other than stake down the USB port properly so it doesn't just snap off when I'm testing it. And then we'll see if we can make sure we can get that to work prior to throwing any of these connectors on. Because honestly, they're too difficult to pull back off to attempt salvage. The way the plated through holes are. It's a shame. It's disappointing, but it is what it is, unfortunately. But we don't know. We might still win. We might have fixed it. I've had boards that are, so problematic, so troublesome that no matter what you do, no matter how much you try, you can't fix them. And you build a new one up okay, that's something better. Not recognized. That's good. Wait a minute. Okay. Okay, that's a positive sign. Device descriptor failed. Okay, so all I'm going to do is I'm going to go clean the flux off. Just in the hopes that maybe it's just shorting some pins out. We'll see. We'll see. Because it is liquid after all. All right. Yes, the wonderful, fun nightmare of problem solving. Yeah, if this fails, I'll probably work on building a board off camera. Just because of how long it takes. I think that's what it was. Okay, now this is what I was hoping to see. So maybe we're in luck. So I don't know if you can see this, but it actually calls out the CP210X. COM23. Please, let's keep our fingers crossed. Because it may not like these chips. Wait a minute, that's a good sign. Please. Oh, booyah! All right, okay, all right. So, sorry for screaming, but having this kind of success like this when dealing with these problems and sometimes reworking parts by hand does not go too well when you have to involve hot air. Damn, that was fun. That was cool. Especially when you got a part like this and we've heated and, so it's gone through one heat cycle with the initial reflow. And then it's gone through all this other stuff, and we've kind of baked this thing multiple times trying to get it to work. So we pulled the old one off, which is a heat cycle on. Even though we didn't reuse the old part, we still heated up the PCB. Then we reheated it, trying to put the other part back on, and then pulling it back off, putting this one on, and then trying to reflow and fix any bad solder joints. So multiple heat cycles. Both the PCB and the chip seems to have survived. So, boom, this is a very big positive. So we got a program. Now let's see if we can monitor. Here we go. Oh, this makes me so happy. So I don't know how well you can see this. I'm sorry if you can't. But that's exactly what this initial test is supposed to do. Okay, so I know I would, to be totally honest with you guys, I was kind of half expecting this not to work. But I'm extremely happy. Okay. All right, so I'm just going to update this. Lag. All right, so, okay. The basic Hello World test works. Look at that. Look at that. Oh, I am so happy and excited right now. Okay, so, I don't have any with me. Darn it. So I'm going to run you through all right, so let's go here to the webcam. All right. So what we're going to do is I'm going to take the printout of the schematics, and even though this isn't perfect because I don't have a red pen, but I want to show you proper process for engineering, like basically engineering change control. Now, you guys are going to have to really stretch your imagination here. This is a red pen. Red pen. All right. So we're going to, even though this is the crappiest printout of the schematics, I got to figure out why it printed this way versus landscape. It's in KiCad. I got to figure all that out. So what's cool is we're already here at the chip, and I'm also going to grab a copy of the BOM. It should still be, yeah, it's right here. So what we're going to do is, even though I had to hand place this part, I've actually validated that it works in this design inadvertently. Now, I don't know if it was just a bad soldering job. I don't know if that's what it was. But moving forward, I'm just going to switch to this chip, so we will be updating the design for that. But the proper way to do that, let's see, that is IC5. Okay, so we'll look at the schematics. It's a little small. So the proper way to redline something is you would just put a single line through it. That's obviously too small. Let's do the BOM instead. I want you to be able to understand this a little bit better. IC5. So you would put a single line through it. All right. And kind of do a call out. And then my handwriting is horrible. After all the years of using computers, I barely wrote anything. Everything was done on computers. So I'm going to put in the internal part number I already used for this part. UPC 2102N -A02. Now, mind you, this would all be in red pen. Dash QFN. No, GQFN 28R. Okay, and then you would initial it, and then the date that you made the change. Okay, now mind you, again, it would be red pen. So then this would go to, in a production environment, let's say I was an assembly tech doing this, or a test tech, a bench tech, engineering tech, whoever, doing this, and there were multiple people involved. The proper process is this would go to like my direct supervisor, and they would hand it to engineering and request an engineering change request. That's something we'll cover. We'll try to roll some more of that stuff in here, but since my plans are to have separate videos that cover specifically QMS processes and things, I think that there would be more value in that, into kind of rolling that type of stuff in and just kind of touching on it in these videos, because there's just too much to cover for one little individual sitting here for an hour. I want to make separate videos, and I know the Twitch stream is kind of more fun with the design and the build and the diagnostic and the troubleshooting aspect. And honestly, to me, that's a lot of fun too. It's been really entertaining, really fun doing this. So we've got some really good positive outcomes here. Now what I'm going to do is, these fly wires probably are not relevant anymore, but what I'm going to do is kind of, all right, so I'm going to go back to the main screen real quick. We'll pull those fly wires off here in a minute after we do some more validation. So right here, put a note at what we had to do to get it working. So we got it working. Again, I don't know if it was a soldering problem, but I don't know. We tried to make sure that other chips, so either it was a bad batch. The only way I would know is to try building up more boards with it, but honestly, I would rather just use a chip that I know and I've used for years. I was trying to save a little bit of money, but there's not much of a price difference between these two models. And the great thing about this version, as long as it's still being made and sold, which I'm sure it is, it's like the upgraded version, is so I can open up Simplicity Studio. Let's, I think it's in monitoring. So minimize that, minimize this. Just show you real quick. So Simplicity Studio is Silicon Labs, their development environment, their ID, their SDK for developing on these chips. And I don't have one with me, but what's really cool is this particular chip has a couple additional GPIOs. For one thing, you can do 485. You can talk to RS-45 with it. And a couple of the GPIO pins can also be configured to drive TX and RX LEDs. So if we wanted to expand functionality of this board, we could add TX and RX LEDs for that chip to just check UART activity over the USB. So it's a slightly, it's an upgraded chip, has more capabilities. And honestly, this would simplify my own personal stocks, because they're not right here. It's showing the device. So we're going to start. I think this is how I'll do it. Preferred SDK. It's loading. So it knows it's, yeah. Yep. Create new project. All right. Custom board, tool chain. I think this will work. It's been a while since I've had to do this. Skip updates for now. So I know I'm kind of going on a tangent here, but I'm kind of excited. No, there's usually a sample project. I'll have to figure this out, why it's not wanting to work. It's like the SDK. Apply and close. Yeah, I'll figure it out. Why I can't load it up. So you use this IDE, this interface, to actually tell that chip what you want it to do. And there's a bunch of other stuff you can do in here, like get a USB vendor ID and actually replace theirs. So let's go here. Basically replace this with your own personal information, if I'm not mistaken. But you have to actually go through the consortium and get your basically your vendor ID and all that for a custom product, and that costs money. I'm not going to worry about that. I don't mind if it shows up as Silicon Labs. I am really happy. So believe me, this is a very big weight off my chest, because now we got this board working and we can proceed. So I'm going to kind of disable a few things, and we're going to go to, hopefully it doesn't complain about that. Good. COM21. This is our FTDI. And this will be really good, because what we're going to do then is we're going to switch back over. So we're going to kind of throw the UART test. Again, after a little bit, I'm going to go and get these fly wires removed. I'll go desolder them real quick. Don't want them flying in the way, and we don't really need them anymore. So if I remember my orientation, boom. That should be the proper orientation. FTDI doesn't really care. So we're going to go back to here. That's going to be COM 21. 21. We're going to go and open it. Really matter. So we're going to go ahead and close this because we've got that working. We're going to go back in here. The UART FTDI test. Open code. This gets to be a pain in the butt. So one of the things that, oh yeah, of course you did. Of course. So we're going to, we'll do a full clean. Then we're going to build it. So what builds, it's got, so this is the UART console that I threw together. I think I customized it for this, but I'm not sure. If I didn't, that's fine. We'll fix it. Yeah, it's fine. So yeah. Finish building. I'm just too excited that I think we've got our problem solved. Of course, there's not going to be anything here because there's no serial port, no FTDI. Fine, so this will be the next step to see if we can get the serial UART to work. And while that's building, that'll be basically the FTDI interface, because that's one of the another core blocks, functional blocks of this device, subsystems that we want to ensure that works, because we're going to need that for a lot of the other tests. So we should be able to get that tested today, hopefully. All right, we're still building. Because there's still a bunch of other tests that we need to do. Maybe we can sling some code together real quick. We'll see what we have to do. Yeah, the RS-45 one's going to be a little bit trickier, because we have to do a bunch of GPIO slinging and stuff, but that's not a problem. We still have to do the PLC program, get it functional. The fan, temperature sensor. Yeah, so we've got a lot. I'm going to have to probably throw the temperature sensor back on here as well. Because I forgot I pulled that guy off, so maybe I can do that real quick too when I'm pulling those fly wires off. All right. Yeah, older computers just run really slow doing everything. Plus running OBS Studio and all these other pieces, other devices. Yeah, I just got to pick up a couple additional USB hubs and deal with that resource issue too. I got to look into that, see exactly what's causing it. Oh, okay, it's not using that. That's fine. All right. So the end goal with these kind of tests. Now, this test is fine. You know, this type of bench test is fine to have to do it this clumsy way. But there are other ways we can do it. We can actually use the ESP program tool and manage it that way. I think I could save multiple profiles as long as the build files, the partition table, the boot, and the actual main binary files are where they need to be, and set all that up. I think I can set some stuff up and use the actual ESP flash tool, which would speed this up. Just load up different profiles and blast them on there. Maybe, but for this type of testing, for this bench testing, it's almost not necessary. I'm more thinking the programs, the firmware that would be needed for the actual production testing, make it as easy as possible. So there's that. We're going to flash this guy. Do I not have it connected? No, it's connected. Is it not mad? Oh, I have the wrong. Do I have the wrong COM port? Oh, COM 23. Yep, I never changed the COM port. Boop. My bad. 3. Please work. You worked for the last. Oh, no. Whoa. All right. So we have the putty right here. Let's do the reset of the board and see if we get anything. Maybe I've got my terminal on backwards. Maybe I made ground up there. Which would be possible. It's also completely possible I've got the wrong pins. There we go. All right. Oh, I see. I see. Terminal. Yeah. So there we go. Your FTDI interface firmware. I don't know. Help. Okay, so we're getting bidirectional communication off of the FTDI port. I don't know if you can see the screen. So we're just going to echo test. I don't have local echo turned on, so let's go to change settings, terminal, local echo, force on. There we go. So basically, echo is the command, and then that would be the argument, and then it's responding echo blah back to me. So that means our FTDI port is working. We've got bidirectional communication at the baud rate specified, 115/200. And the ESP32 is at least processing tasks with free RTOS and its UART driver. This is actually so far a win. We are really getting there. We have finally made some serious progress with this guy. So it's a pass. So that is a pass. Now I think what we can do is kind of slam some real quick firmware together. Let us shut this guy down because he's going to complain anyway. Oh, that is so happy. Such a happy day. So I'm just going to pull this guy out of here. Yeah, let's see here. Yep, okay, I must have made pin 1 ground. Yep, it's easy without a diagram. I'm going to have to, yep, I made pin 1 ground. Okay. I don't remember doing that. But it's okay. It doesn't really affect anything. Let's grab my flux, my solder wire, put it over here. Over here. Switch to that camera real quick so you can go on that journey. Oh, it's going to get mad at me. Webcam. Oh, no, it's not. Okay. Or it is. Hello, webcam. Webcam. There we go. Yeah, I know. I'm like all over the board, but you know, that's how this stuff goes sometimes. So I'll have to make sure to maybe tomorrow's stream during the afternoon, we'll kind of go into catch up on some of the administrative stuff that we haven't. Just trying to find the temp sensors in here. I hated wasting one, but I have to rule out all possible problems. Unfortunately, that's the name of the game. Sometimes you just gotta waste a component just to rule it out as being the problem child. Here we go. temperature sensor. All right, huh? So first things first, get this guy warmed up. Solder wick and my nice cutters. All right. First things first, let's get these air wires off. Oh, come on. Come on, buddy. Oh, that's a ground, that's why. And that's after even putting a new ESP32 on here as well. Set those aside. They're still usable. So yeah, I put a new ESP32 on here. So one of the administrative things we're going to have to do is also go into our inventory, our ERP solution, Odo, and basically tell it to, we can, we've built the board, so we need to consume the parts out of inventory. And then we also need to remove the additional parts that we use during troubleshooting and testing. We'll have to go in and update the design for the other chip. Have to add it, schematic symbol and everything, which isn't a problem. It's got the same footprint. It's a pin for pin drop-in replacement, so we just get a new schematic symbol. I can probably update the existing symbol. Well, create a new part number for it, create a new library entry for it, because that's the way to go. And then copy and assign the pins to their new designations. Like I said, I like this chip better anyway. I don't want to take any chances that that other chip is what was causing my problem in the first place, because it very well could have been. Maybe it just didn't like it. Windows didn't like it. Windows apparently likes this chip, and I'd rather stick with it anyway because it just works. It's always worked for every project I've used it in, and I'm just going to stick with what I know and what I know works. Flux pin. Again, trying to keep you guys in the loop, but it's difficult sometimes, especially when you're so used to doing this on your own, without being scrutinized or viewed by others. Dab a little bit of flux. Get a little bit of fresh solder here. I'm going to do one pin. Got my handy dandy microscope, or handy dandy, so it's a little bit rotated this way. So what we're going to do is just kind of pan the butt. That's perfect. So, yep. So I only tagged the one leg to make it easier to reposition. This guy's still wanting to work. Okay, I didn't complain about that, but microscope. There we go. So yeah, it looks all messy, but so that's the part. Only the one leg is soldered. That way, like I said, it makes it easier to position. Now I'll go through and smack the rest of the solder on for the rest of it. And that'll be quick and easy. Quick and functional. Again, don't be afraid to use flux. It is your best friend. Yeah. Oh no, I got a bridge. What will I ever do? Flux. Clean off iron. Flux. Long drawn out pain in the ass method. This method just takes forever to get it to work right. Might have to use a little bit of desoldering braid. Maybe they got it. Nope, you're still there. Stubborn little fella. Stubborn little solder bridge. Stubborn. Hate little bridges that don't want to. Oh, wait, I got it. Yes, sir. Takes a little bit of time, a little bit of effort. It's like everything else in life. A little bit of time, a little bit of effort. All right. Handy dandy little towel. Got my handy dandy little water jar. Getting some stuff in to make this a little bit easier on me. Now, hopefully, when we get to any level of production or further down where we're building a lot more boards, maybe even for some testing, maybe to hand to people I know who would be interested in working with these for their own projects, to kind of like little field testers. Some of the guys I work with who dabble around with automation and stuff and robotics, they might be interested in working with this. They might be able to test some for me. Hopefully we don't have to do any more reworking. Because the goal is as little as possible. Because one of the things in this industry is one of the general rules that you need to follow that you'll learn is, especially as you scale up production, is the more human hands that touch it, the more expensive it gets. So if you're a customer, just keep that in mind. So if you like design but you don't want to build and you want to outsource to a production company, just keep that in mind, to a fab house. The more times a human hand has to touch it, the more expensive it is. That's where your cost is. Pick and place equipment, dirt cheap. And it's such a competitive market, but it's the human labor that costs you. All right, let's go back to the microscope. Oh, look at that. Just like brand new. Just like grandma used to make. So that's perfect. You got a little bit over on this capacitors, but that's what happens when you design a really tight board. It could have been tighter. I could have had the capacitor shoved even closer, idealistically, but yeah, I do want to take into consideration human hands maybe touching or reworking the board. So that's why I did not do such a thing. So, without further ado, we are going to just make sure that nothing got damaged, nothing got fried. Oh, it makes me so happy. And it's a happy sound hearing the USB say, "Hi, I'm here." Okay, still COM 23. We're going to do another flash attempt. And COM 21. Don't know why I closed that out. Oh, you know what? Yep. It helps if the FTDI cable's actually plugged in. Oh, I forgot. I didn't save the actual putty settings, but that's fine. I didn't save that, so let's just show you where that is, just in case here. I'll load that, then we're going to go to terminal. Force on. Implicit. Go back to session. We're going to save. Load. 21. There we go. Sometimes it doesn't like that. Ah, okay. Maybe one of my sessions. Oh, you know what? It probably is. It is probably that. Oh. Why did I do that? I am such an idiot. Load, terminal, auto, line feed, session. We're going to save. And we're going to be at 21. Nope, 21, you goofball. Okay. There we go. Clear. All right. Yeah. Okay, so it's not Yep, okay. Okay, so that's my session settings. Need to be cleaned up a little bit, but you get the gist. So our terminal is working properly. You know, that's going to honestly drive me freaking nuts. I hate that PuTTY has to close completely. Why can't I just cancel, you know, close a session? Terminal, police and carriage return, local line, so force on. Line feed. Maybe that's the one that I need to do. It drives me nuts sometimes. Yeah, I want to close a session, but I don't know why I have to keep doing that. Load. Yeah, this is just me. Maybe that's what I needed. Session. Save. Okay. There we go. Okay. Whew. That's what I want it to look like. It's just a little bit easier to understand what you're doing when you're using it. So good. We didn't damage anything. We actually fixed it. The program, so definitely the temperature sensor was not causing the problem with bootstrapping or anything, because now it was on there and we managed to load it again, so that wasn't causing a problem at all. So the next thing is to jam out some firmware. Might as well have you guys with me on the ride for that. I don't know if we'll be doing that tomorrow. Maybe tomorrow we'll catch up on a few little things, because I don't want to get too far. I don't want to run too far ahead with testing and doing all this other stuff and let some of the administrative stuff linger. Because, you know, I want to, you know, go through, finish out the manufacturing orders like I should have done by now. I want to update the BOM for the board, add the new part. I'll lie that, you know, we'll consume the old part. We'll have to do some things to basically scrap the old parts that I consider bad. And we'll go from there. So tomorrow will probably be like an administrative catch-up day, a stream. And then Sunday, hopefully we can get into some coding and some more further testing so we can get this further along. There's a lot to do, and I hope you'll join me on this adventure as we continue moving forward. But for today, for this wonderful Friday evening, I thank you for hanging out with us. And today I think was a glorious day, and you got to see troubleshooting and how this works, you know, for real. It's you know, you don't always build a perfectly working board, you know, first time around. We got lucky. We really did. So far, everything's working fine. We'll know more once we dig down further into the other subsystems. But so far, keeping our fingers crossed. So have a good rest of your evening, and catch you guys tomorrow afternoon around 2 for our Twitch stream. Take care.